Now that we've learned so much about metals and non-metals, I'm sure you must have guessed a few important applications for both. If you're asked for the uses of metals and non-metals, don't you think the list would be too long to note down? Yes, but we will still try listing a few important uses in general. Let us begin with the metals first. Can you tell me the most important physical properties of metals? Yes, luster, ductility, malleability, conduction of heat, and sonority. So can we mention a few uses based on these properties? The fact that they are lustrous makes them useful for making jewelry. Yes, metals are lustrous, which means they generally shine. We can also make wires out of metals due to their ductile nature. And what if we beat the metals with a heavy hammer? We don't have to worry. They are hard enough to not break. Also, the fact that they are malleable can help us form thin sheets out of the metal that is hammered. And where do we use their property of conduction of heat? Yes, we can make kitchen utensils out of metals so that cooking becomes possible and convenient. Also, the bells used for conveying messages in various forms are made out of metals due to their sonorous nature. Now, can we say that metals are used in almost every commodity that we use in daily life? Absolutely. So are metals more important than non-metals? Not really. Even non-metals play a major role in our daily lives. Just imagine if we had no oxygen in the air. There would be no life. Not only this, but several important processes like purification of water and synthesis of important chemicals employ many non-metals. Many fertilizers and even pesticides are made out of non-metals. Non-metals have an extremely important use in medicine as well. Do you know the purple-colored solution that is applied on wounds? Yes. That antiseptic solution contains iodine, which has germicidal properties. So yes, metals and non-metals both play extremely important roles in making our lives better in their own different ways. We take the same sample of metals to check out how they react with water. Don't forget our basic aim, to find out the order of reactivity of these metals. If a metal reacts more vigorously with water, then it is said to be more reactive than the one that doesn't react as much. In general, metals react with water to form metal oxides and hydrogen gas. And if the metal oxide formed is soluble in water, it will dissolve to further form metal hydroxide. So how can we judge the order of reactivity based on their reaction with water? We perform a simple task. First, we take a beaker half filled with cold water and see how the metals react with it. Some of the metals will react with cold water, but most of them won't. Out of those metals which didn't react with cold water, we try to add them to hot water and see how they react. Again, some will react with hot water and some won't. Those that don't react with hot water, we see how they react with steam. And that will kind of give us the order of reactivity. Ones which react easily with cold water are more reactive, and the ones which required steam to react are not as reactive. Metals like sodium or potassium react violently with cold water. In cases of these two metals, the reaction is so violent that the evolved hydrogen immediately catches fire. The equations look like this. This hydrogen catches fire immediately after the reaction. That's how vigorous the reaction is. So we know that sodium and potassium are very reactive. Remember, we're still talking about reaction with cold water. How does calcium react with cold water? Well, calcium does react with cold water, but the reaction is not as violent as what we'd seen with potassium and sodium. The heat is not enough for the hydrogen to catch fire. But what happens is that the calcium starts floating because bubbles of hydrogen gas formed stick to the surface of the metal. And magnesium? Does it react with cold water? No, it doesn't. But magnesium reacts with hot water to form magnesium hydroxide and hydrogen gas. And just like calcium, it starts floating due to the bubbles of hydrogen gas sticking to its surface. The remaining metals we see here don't react with hot or cold water. But aluminium, iron and zinc react with steam to form metal oxide and hydrogen. And the other metals like lead, copper, silver and gold don't react with water at all.